All right, this is number 4. You'll notice that each of these has been a little bit different, where the points were, where they laid, how that affected the graph, what that meant we needed to look for. Okay, so this one will be, again, a little bit different than the first 3. So let's go ahead and consider it. This is a quadratic because it's in a x squared plus bx plus c form. We know that a equals 1 because that's the number in front of the x squared. We know that b equals 4, and we know that c equals 6. Now, the first thing we're going to try is the discriminant, which is b squared minus 4ac. And note that I write this every time. You should write it every time too, because the more you write it, the easier it will be for you to remember it. So I've got 16 minus negative 4 times 6 is negative 24. So minus 24, which is negative 8. Now, negative 8 being the discriminant, that means there are no x-intercepts. Okay, now notice that the number in front of the x squared is positive, which means it's going to be a u-shape, which means it's going to be something like this up above the x-axis with a u-shape and no x-intercepts. So there's no use to finishing the quadratic formula. That's the value of the discriminant, is that we now know that it would have been pointless to do all that work. So let's do what we can do. Let's go for the y-intercept. To get the y-intercept, we put x 0, so we go y equals 0 squared plus 4 times 0 plus 6, which gives us y equals 6. So when x is 0, y is 6. So we put down the y-intercept right there. And then we go on and let's do the vertex, because I don't really have anything else to do. So the x value of the vertex, now remember that's just the x value. The vertex is a point, so the x value is negative b over 2a. So we go negative b being 4 over 2 times a, which is 1. So negative 4 over 2, which is negative 2. So the x value of the vertex is negative 2. Now to get the y value of the vertex, we're going to take that negative 2 and put it back into the original equation. So we'll go negative 2 squared plus 4 times negative 2 plus 6. So I've got the y value of the vertex is negative 2 squared, which is 4. That's why I put it in parentheses like a good little Algebra 1 student. And then 4 times negative 2 is negative 8, and then plus 6. And I end up with 4 minus 8 is negative 4 plus 6 is 2. So that would be 2. So when x was negative 2, y was positive 2, right? X was negative 2, y was positive 2. So we go ahead and put that down, negative 2, 2. Now that is also, the x value of the vertex is also the position of our axis of symmetry. So we'll draw that in. Now from there we can kind of fill in the points. So this point is 2 spaces to the right of my axis of symmetry. So I'll draw that one 2 spaces to the left. Now I can get one more set of points. I can either put in a positive one, which I expect will probably be right off the graph there, but that's fine. You can do that if you want. Or I'm going to go ahead and put in negative 1 just because that'll give me the point in between. Now, if you know what this quadratic looks like without being stretched, you can probably guess already that the points are going to be there, and then you're already done with your graph. And I'm okay with that if you know absolutely for certain that that's where they're supposed to be. Now, if you didn't know that, then we'd get one more point by going x equals negative 1 and plugging it in. Y equals negative 1 squared plus 4 times negative 1 plus 6. Now, again, you could have chosen any number. You could have chosen negative 3 and plugged that one in. It's just negative 3 is hard to work with the negative 1. In addition, you could have put in a positive 1 or 2, but like I say, I'm expecting those are probably going to be right off the graph. So rather than that, I'm going to choose a point in between the ones I already have. And so negative 1 squared is positive 1. 4 times negative 1 is negative 4 plus 6. And I got 1 minus 4, which is negative 3, plus 6, which is 3. So when x was negative 1, y was 3. So right there, and sure enough, that's the point that we knew it was. We reflected on the other side, 1 space away from our axis of symmetry. And you got it. That's all there is to it. Our graph is done.